Last case. So this is the last video in this sequence of your soft chalk. In this case, we're back to having an EMF source. So we got a battery in here. But what we're going to do is we're going to say that the initial charge on our capacitor is 0. Okay, now what that does is that means this term here is gone this time. Okay, so we've got Q equals CE e to the minus T over RC minus 1. Okay, so we begin with that. So let me just write that down here. Q, all right, we've got CE e to the minus T over RC minus 1. Okay, now the charge on a capacitor is equal to the capacitance times the voltage on the capacitor. Okay, and so if we make this substitution, then it's kind of fun. Our C values are going to go away at that point, and we can see that the voltage on the capacitor at any point in time is just going to be whatever the EMF value is, e to the minus T over RC minus 1. Okay, now let's go ahead and graph that here. So time here, and we're going to do voltage, and so we've got our EMF value here. Now at time 0, e to the 0 is 1, and when that happens, we've got 1 minus 1, which means this whole term is 0. Okay, and so what happens then is it comes up like this. Okay, and we have this asymptotic behavior where the voltage on the capacitor gradually becomes whatever the value of the EMF voltage is. Okay, and by the way, we have a similar sort of thing with the charge. Okay, so this CE is really going to turn out to be our maximum charge, and we would have something similar where it's going to come up to whatever Q max is here. Okay, now usually we're not all that interested in, but we might be interested in that. So let me get rid of those things, clean this up just a little bit. Boop, there we go. Okay, so there's our voltage. Okay, now in addition to voltage, just like in the last case, we need some kind of way of talking about the current that's going to flow. Okay, now when we first close our switch, okay, current begins to flow here. And remember, this is like a pipe with the little bulgy ends. Okay, so current causes this thing to expand, it bulges and bulges, and so the current slows down over time. Okay, and it's eventually going to stop because this little bulgy bit will have generated so much back pressure, then it's going to stop the flow of the water. Okay, in this case, so much voltage, it's going to stop the flow of the current. Okay, so we do that by, to figure out the current, we're going to go back to I is dq dt. All right, so I've got my CE here, and then I need e to the minus T over RC. Okay, so this is the trick with e to the AX again. All we have to do is bring the A down. So we're going to, once again, we're going to get minus 1 over RC, e to the minus T over RC. And the minus 1, when we do that derivative, we get 0. So this is what we got here. Okay, and this is kind of fun. So my C is going to go away, boop, just like that. Okay, and so we're going to get that I is minus over R. Okay, and again, the negative sign doesn't really matter because that just indicates direction. Okay, so like if it's velocity, that just means it's to the left. Okay, so if we said the speed, we wouldn't care that it was to the left. We just want the magnitude. Okay, and then we've got e to the minus T over RC. Okay, all right. Now this right here, okay, if we use Ohm's law, that turns out to be whatever the initial current is, because Ohm's law is going to tell us that the EMF is V equals IR, just like that. Okay, so I is E over R. Okay. And we're going to call that I naught for the initial current. Okay. Now, so what that means is if we mark over here the initial value for the current, it's dropping off exponentially. Like so. Okay. So the current is dropping and the voltage is increasing, and they're kind of like passing like ships in the night. Okay. Just like this. Okay, there you go. So I've given you a lot of information here. And so we're going to use some class time to sort of reinforce this, do some examples, that sort of thing. I don't want you to feel like you're hanging high and dry. So we'll, anyway, we'll work on helping you get a good grip on all this stuff that's happening here. Okay.